Hi guys, today we're going to look at momentum. So, would you rather be hit by a tennis ball or a bowling ball? So, I assume that you all said that you'd prefer to be hit by a tennis ball than a bowling ball. But what if the tennis ball was moving at 200 meters per second and the bowling ball was going really slowly? Would that change your answer? If you said yes, you are correct. This is what momentum is. Momentum is the impact that an object has. It is its mass times its velocity. And this is what we're going to be looking at today, the impact that an object has, its momentum. Okay, let's get these definitions out of the way, and then we can look at how we can calculate the momentum. Momentum is the mass times the velocity of a value. This means that as we increase the mass or the velocity, the impact that a certain object has increases. This is our momentum. We show momentum with a letter P. The unit of momentum is the unit of mass times the unit of velocity. This gives us kilogram meters per second. Okay, let's have a look at what we mean by momentum. So I have a red ball. The yellow arrow is going to show me its momentum. That's its mass times velocity. And the green arrow is going to show us velocity. Okay, so as this object moves, it has an impact. The impact is the yellow arrow. That's its momentum. We can see here that when I increase the ball's mass, the yellow arrow, which is its momentum, increased also. That means that the impact that this object would have is much bigger. And vice versa. If I decrease its mass, I'm going to decrease its momentum. Momentum has a direction. So because it has a direction, the direction matters, it means that the momentum is a vector value. Please fill in this section of page 6 in your notes. So when two bodies collide, they transfer their momentum between each other. This is called the law of conservation of momentum. It states that the momentum before a collision is equal to the momentum after a collision, providing no external forces act. We can use this law to do calculations involving momentum because m1u1 plus m2u2 is equal to m1v1 plus m2v2. This means that the momentum of both bodies before the collision is equal to the momentum that both bodies have after the collision. Okay, so let's look at this one more time. So I'm going to have ball 1 with a certain velocity, which means the object will have a momentum. When ball 1 collides with ball 2, they will move off together. The momentum before the collision, so the size of the arrow before the collision, is equal to the size of both arrows after the collision. This is the law of conservation of momentum. So now we're going to put some numbers onto this equation and see if we can do a calculation involving the law of conservation of momentum. Okay, in this question we're told that two shopping trolleys, each of mass 12 kg, are on a smooth level floor. Trolley A is moving at 3.5 meters per second and strikes trolley B, which is at rest. After the collision, both trolleys move together in the same direction. Part 1 asks us to find the momentum of trolley A before the collision, and part 2 asks us to calculate the common velocity after collision. Okay, the first thing I'm going to do here is draw a diagram of what I have. If we go back on our notes, we can see we have a few steps to follow when doing calculations involving momentum. The first one is to draw a diagram. So here you can see I have trolley A, trolley B, and after the collision, trolley A and B are stuck together. Underneath each trolley, I write down what the initial mass is, what the initial velocity is of both systems. And after the collision, I write down what the mass of my system is and what my velocity is. I can see that after the collision, because the two trolleys move off together, the total mass is m1 plus m2, which is 12 plus 12, which is 24 kg. Okay, now I have my diagram. Let's see what the question is asking us for. Calculate the momentum of trolley A. To find the momentum, P is equal to mv. So we substitute in our mass and our initial velocity for trolley A. So our momentum is equal to 12 times 3.5, which gives us 42 kg meters per second, which is our unit of momentum. Okay, part 2 asks us to find the common velocity of the trolleys after the collision. In this case, we need to use our law of conservation of momentum, which states that the momentum before the collision is equal to the momentum after the collision. We write this down, and from here we can change this into an equation. Okay, let's just flick back on our notes and look at our calculations involving momentum. So we've drawn our diagram. Now we just need to substitute in our values to our equation. Momentum before equals momentum afterward. This gives us m1u1 plus m2u2 is equal to the momentum after, which is the mass after a collision, m1 plus m2 in our case, times the velocity after the collision, which I'll call v. And from here, I'm going to substitute the values that I have into my equation. So where I see m1, I write 12, u1 3.5, plus 12 times 0 equals 12 plus 12, which is 24, times the velocity, the value that I'm looking for. Okay, let's just solve this out. So we have 12 times 3.5, which gives us 42, plus 12 times 0 gives us 0, equals 24v. Okay, we want to solve for v. So here I have 42 equals 24 times v. I want v on its own, so I divide both sides by 24. This leaves me with v equals 1.75 meters per second. This is the velocity of our two trolleys after they collide. Okay guys, in your notes I want you to go to exercise 9.3 and try questions 1, 2, 5 and 6 using the same equations that I have in the example. Momentum is equal to mass times velocity, and then if you're dealing with two systems, the momentum before the collision is equal to the momentum after the collision.